Hi, welcome to PR Tech Talk. In this video we are going to do a project using the SPI interface on the Renesas RA2L1 board. The same can be adopted to all Renesas RA microcontroller boards. You only need to take attention to what pins are connected physically to the PMOD2 connector. They can vary. We are going to connect the 96 by 64 pixel RGB OLED display to the PMOD2 connector. The display are named PmodOLEDrgb from Digilent, and they are using a controller IC from Solomon named SSD1331. I will put a link to the display in the description below. To do this, we first need to create a project in Esquare Studio, and I'm using the FSP 2.3.0 in this video. Then we need to use the FSP configurator to configure the SPI into the project, taking care of naming the pins correctly so they match the code. I found an SSD1331 library on GitHub and made some changes to it to fit the Renesas RAFSP, the software used in this lab. You can download the code from my GitHub page. So enough talking, let's get started and launch the Esquare Studio. Okay, so we have started the Esquare Studio and we need to start a new project. So we start with File, New, C++ Project, Renesas RA, Next. We give it a name. We select which board we are using, and this is the RA2L1 board that we are using. We continue with the bare metal minimal. We open the perspective, and that is the FSP configuration perspective. So now we open, so we immediately go with stacks, new stack, driver. We go with connectivity. And we go with SPI driver on RSCI underscore SPI. Down here we can see some information on the module, on the properties, and the channel that is connected on this PCB is the channel number 9. We go down to which pins that are selected. And here on CTS, this pin we will be driving manually as GPIO, so we need to deselect that one. Else we see that this is a simple SPI, and we see that P203, P204 and P204, 202 and 204 are the ones that are used in this SPI interface. We deselected this pin, so we need to drive that on our own. So we go with pin 205 and we change this symbolic name to match what we have written in the code, and that is CS with capital letters. And here it says that it's disabled, so we need to enable it as output, and we put it as initial low on everything. So that was pin 205. The next pin that we are going to use is the pin 409. And we need to change the symbolic name here as well, so it matches the written code. And we have it here as DC. We need to change the input to an output, initial low. We remove the IRQ. And we continue with the next port pin, and that is the pin 303. And we change that to RST. The next pin we are going to use is the 206. And we also change the symbolic name here to VCCEN. And the last pin is the pin 304. And that is named PMOD enabled. So the project is created, and we can now try to build a project before we have started anything, and it builds without any errors. Okay, good. So we open the file for source, and there we need to include some files which I have prepared, and you can download them from my GitHub page. Like so. And we also need to make some changes to the whole entry C file. So we can change the perspective up here to the C++ perspective. And we double click on the whole entry C file to open that one. First of all, we need to make some includes. Now that is done, we need to make an external variable. Like so. And then we go down to the main loop here. Add your own code here. And we give us some space. We don't need so much space, but anyhow. So first of all, we need to do an init file. Or called init file. So we have it there. And I also made a small demo loop demonstrating all the features of the software graphic library. So we just call it from demo there, and we can take a short look at it here. So first of all, we have the init file where we open the SPI port and trap if there was any errors, and we send it to the Sega RTT. And then we use the GPIO pin rights to toggle the port pins that is connected to the SPI display. And afterwards, then we send the initialization commands to the display according to the data sheet that is needed. And then we return back to the hal.entryc file. And then immediately we call for the demo file, and I think I put it down here somewhere. Yeah, here, demo. So what it does here, it's writing the string demo to the buffer, and then it puts the string to the display, and it erases the display, and then it writes some lines, etc., etc. So this is where you can have a look in all the different versions that the software can do, and you also see the corresponding activities on the display. So we built a project. There was a lot of warnings, and if we take a look at the warnings, there is some coming from this library here. If we don't like the warnings, we can, get them to disappear by just building it once more. that is not the right way to do it. The right way is to address all the warnings, but it works anyhow. After that, we can download the code into the microcontroller. And then it changes to the debug perspective up here in the right corner. We can then hit resume and it stops immediately at the HAL entry. That is the normal procedure, so we need to resume once more. And now the code is running on the display. Okay, so this lab worked fine. The SPI port was configured to the PMOD2 connector. RGB OLED demo loop shows strings, lines, circles and graphics. There is a lot of demos to do on your own. In this lab, I used the EK RA2L1 board from Renesas. But the same lab can be used on all Renesas RA boards. You only need to take attention to what pins are used to the PMOD2 connector if you select another board. Please also take a look at my other videos, for example, the FSP installations or the Sega RTT viewers. If you liked the video, please subscribe and like, and also put a comment. Hope to see you in the coming videos. Stay safe.